The last class we were discussing that we have a table, and on this table we have some object, suppose this. Then this object is kept, this table is on the ground. Now there is a force of mg acting on this object. So first thing we will see what are the different forces acting and how the Newton's according to Newton's third law, how the different forces are in action reaction pairs. So if mg is acting on this object, so what is the reaction pair for this mg? So the reaction pair will be on the earth, at the earth center, because earth is exerting this force mg. So this force mg is between earth and the object. So between earth and the object A. So the pair of this force, the second pair of this force, the reaction pair, will be from the object on the earth. So earth will also experience a force mg. But we have another force present here on the object, that is called normal. And since the object is not moving, the normal is equal to mg. The normal is balancing the mg. But here the normal is not the action reaction pair of mg. Normal is equal in magnitude to mg and opposite in direction, but still it is not the action reaction pair, because normal, the mg is exerted by earth and normal is exerted by table. So these two are two different things. So we cannot say that the normal is the action reaction pair of mg. So then for normal, what will be the reaction pair? So normal is exerted from the surface of table. The normal is exerted from the surface of table. So the table will also experience a normal force from the object. So this normal is the action reaction pair. So the normal on object is action, then normal on table from object is reaction. Okay, so and mg we have already, for mg also we can write mg, if mg is action, then mg on earth, mg on object, if mg on object is action, then mg on earth is reaction. So this is the example, and from here you can understand how the Newton's third law forces appear. Any doubt in this one? See, walking. So what happens when we walk on the surface? So suppose a person is walking, then he is exerting a force on the earth in backward direction. So he is trying to push the earth in backward direction. So earth experiences a force like this, and as a result earth applies a force in forward direction on the person, and therefore the person moves. So this is also an example of Newton's third law. The person is applying a force in backward direction and the earth is applying a force in forward direction. And you can notice that the action reaction pair of forces are actually the same kind of force. You cannot have one force as normal and other force as friction, or you cannot have one force as gravitation and other force as friction. So the both forces are same. Here also we saw that these two are, both are normal, and here you can see both are mg, both are gravitation force. In this example also you can see this force is friction and the backward force is also friction. So we can say if friction force on person in forward direction is action, then friction force on earth. Friction force on earth in backward direction is reaction. So this one is very simple. Okay, so in walking we apply the forces like this. Next we are going